Hello. Good evening. Can you hear me? So, yeah, I'll share my screen. And I hope this is visible. Hmm? Hello. This is visible, right? Okay. So if so, then we will wait for 1 or 2 minutes if some other people join. Otherwise, I'll start. Maximum 2 minutes. Okay. Okay, so welcome everyone to the tutorial of week 6 for calculus of one real variable. Okay, this is Rahuldev Ghorai from School of Mathematics, IISc Thiruvananthapuram, and the course instructor is Professor Joydeep Dutta. So for this week, what are the topics has been covered are this. So first is calculating indefinite integrals. So it's some part we have done in the previous week also, and then improper integral, mostly improper integral and application of definite integral. Mainly you can compute areas, volume, or other physical quantities using that. And improper integrals are, like let's say 0 to 1, 1 by x, this type of, you will see this is not convergent. So but and also that this function 1 by x has infinite discontinuity infinite discontinuity at x equal to 0. So this type of integral will be called improper integral. How do you say that it is convergent or not? And mostly you have seen, Sarah has also told, if you have like let's say 0 to 1 by x dx, that is easy to uh, understand the limit of this. What you will do, because at 0 you have problem, what you take epsilon to 1 by x dx. Now you can compute this integral, because this integral is like not now improper for each epsilon which is strictly greater than 0. You can write epsilon plus 0 tends to 0 plus epsilon tends to 0 plus, then it will be ln of x, and which from epsilon to 1, then it will be limit as epsilon tends to 0 plus ln of 1 minus ln of epsilon. And you know this limit, it is ln of 1 is uh, 0, so epsilon tends to 0 plus what you have is negative of ln of epsilon. And you know the logarithm curve which looks like this. So as epsilon tends to 0 plus, this ln of epsilon will be minus infinity. It will converge to minus infinity, and so it mainly diverges. So it tends to, or the limit is infinity. Okay, so it diverges. So 0 to 1 by x dx is diverge, so it diverges. Okay, so improper integrals are, you can think of like the limit of this proper integrals, which are like 0 epsilon to 1, we do like this. So it's a like this type of ideas like you can use in many other evaluating in many other integrals which are difficult also in like this is one simple one I wrote. But in general, how do you show that? I hope you all of you were okay with the improper integrals things, and also if not, you please tell. If any theoretical you have problem in theory, otherwise I'll be doing some examples. Okay, dx over x minus 1 to the power mu, when it's convergent. Convergent in the sense of this, so this one is divergent. So if it is a limit is finite, sorry, if limit is finite, if finite limit, then it will be, we say, convergent. It converges. In this case it is diverges. Okay, so that's the thing is whether, so when convergent, so convergent. So this type of integration, like it's a very basic thing to ask, because dx by x minus 1, in many places you have seen, but also you will see dx over x minus 1 to the power mu, let's say. Then when it will be convergent, can anyone guess here? At least what, like depending on the mu value, can you say something? For can you give me one value of mu for which it will be convergent? First of all, for this question, we have to find convergence of, this convergent of the, for what are the values of mu you have convergence. But can you give me one mu for which it convergent? It converges. Yes. If you are not speaking, I have to then check the message. Whatever, any mu values, mu, if you see the mu, if you mu is 0, let's say mu is 0, then the integration becomes a over a to b dx over 1, right? And that is nothing but integration a to b dx, and that is, you know, b minus a, right? That is always convergent there. You don't need to do any, it is a proper integral and you can integrate it, right? As for mu is equal to 0. Let's say mu is like negative, mu is less than 0 also. When mu is less than 0, let's say mu is equal to minus m, where m will be greater than 0, so always you can do like that, right? And in that case, it will be a to b x minus a to the power m dx. And that, you know, you can easily compute x minus a to the power m plus 1 over m plus 1, and that you go to from a to b. That implies at a it will be 0, but only at b it will have value, and this value will never be singular or something, because it is mu is equal to minus m. So mu when is less than or equal to 0, don't have any problem. It's a proper integral, it's convergent, okay? So that you can show like this. But what happens when mu is uh, greater than 0? What is the, like, there will be a problem, right? So but can you say something more if mu, can you always say if mu is greater than 0, there is divergent? We know already mu is less than equal to 0 is convergent, but can we say we have mu greater than 0 it is divergent? What do you expect? So the thing is, mu greater than 0, for all mu greater than 0 is not divergent. It is convergent for a range of mu value. So that we will see. That is important. Okay, so how we will see that? So okay, so we'll do the same trick. So we have a to b dx over x minus a to the power mu we have, right? Yes, and mu is greater than 0. Let's, that is equal to, it's a limit. What, where is this function has problem? B is not equal to a and b is strictly greater than a, that we know. That is like this given, let's say. So then what, 1 by x minus a to the power mu, if mu is strictly greater than 0, will have problem. It means it has infinite discontinuity at x equal to a. At x equal to b, it is not a problem. Okay, so non-zero function does not blow up there. So that will be, so that's why, so you have no problem here. I'll just delete this. Yeah, and so what you can write then, so to make it proper integral, so what we do, epsilon tends to 0 plus dx over, sorry, integration of a plus epsilon, right? Instead of 0 we had epsilon, so now we take a plus epsilon so that it does not include a, because a, you have a and b like this, and then a plus epsilon will be somewhere here, and as epsilon tends to 0, a plus epsilon will go to a, right? So that's what we are using here. Okay, I'll just erase this and then I'll again write. So you will see how we'll get to know about the mu range using this epsilon definition. Epsilon tends to 0 plus a plus epsilon to b. Sorry, I will not write again a plus epsilon to b. We'll evaluate this now. Okay, what will be this integration? X minus a to the power 1 minus mu over 1 minus mu from a plus epsilon to b, right? So that is nothing but limit as epsilon tends to 0 plus x minus a, at b it will be b minus a to the power 1 minus mu over 1 minus mu, minus, if you put a plus epsilon there, it will be epsilon to the power 1 minus mu over 1 minus mu. And if you take limit this b minus a to the power 1 minus mu over 1 minus mu has no issue, because epsilon, it is independent of epsilon. It will be going to limit as epsilon tends to 0 plus epsilon to the power 1 minus mu over 1 minus mu. So when this limit exists, there is a question. Whenever limit exists, in that case this integration will exist. Otherwise, it will not exist. Depending on this last term. So it depends mostly on. I'll mark this as the vital point. So let's put it in the green color. So it depends on this term, mainly, right? So it mostly only depends on this one. So then now can you say when this limit exists? Nitish, can you speak? Maybe I can't. Like you asked something last sometime way back also. I have some microphone issue or something. Otherwise, if you speak, that will be good for me. Like otherwise, I can't. I have to always check the message. So you ask something like this. For this one, mu is equal to, see, not when mu is equal to minus m, I chose m greater than 0. Is mu is a real number which is less than 0. So any real number which is less than 0, you can write that as negative of a positive number, right? Let's say you have a mu is equal to minus half. That you can write as, yeah, I mean that's a minus m, right? Or any thing which is negative, that is nothing but negative of a positive number, right? Negative time a positive number. That's what I wrote. M has to be greater than 0. So I'm giving answer to your first question in this. So that is, you were asking how mu is equal to minus m, then m greater than 0. So I did not write mu is equal to minus m, then m greater than 0. I wrote mu is less than 0, then mu is equal to minus m, where m is greater than 0, any real number. Yeah, mu is real number and m is a real number. Now do you understand, or like you have to say? Okay, so you said okay, and then you are now I am asking this one to both of you. You told if mu is equal to 0, then it will be, see, mu is already strictly greater than 0. I have mu, when mu is equal to 0, we don't need to do this epsilon definition here. So you need to have only this when mu is strictly greater than 0. So, but still, we have some, like, can we have a range of mu? For that, this will be converged into divergent, this epsilon. Yeah, when epsilon tends to 0 plus mu is a fixed number which is greater than 0, right? Strictly greater than. It is not converging into 0 also. Right? So when epsilon tends to 0 plus, depending on the mu value, it will be converged into divergent. If you see, if mu 1 minus mu, this quantity is greater than 0, then it will be always converging to 0. If 1 minus mu is less than 0, let's say 1 minus mu is equal to less than 0 means minus 1 by 3, let's say, then it will be 1 over epsilon to the power 1 by 3 times Is 1 minus mu is 1 by minus 1 by 3, right? So it will be minus 3 times this. And limit now as epsilon tends to 0, this will see blow up, right? So epsilon tends to 0, it will blow up. So you will see 1 minus mu is less than 0, then you have this epsilon to the power 1 minus mu will be divergent, right? And 1 minus mu is greater than equal to 0, it will be, so as epsilon as 1 minus mu will diverge, so tends to 0, so tends to infinity as epsilon tends to 0. And yeah, so what till now what we have done, so this is like not till now for this question. So this case 1 mu is equal to 0 is okay, and mu less than equal to 0 also okay. We have shown that these are the, like it has a value, so it's convergent, and mu greater than 0, we get this as like, as we have to take like this in just plot the point A, so we take A plus epsilon, and then we see this we get up to like this limit epsilon tends to 0 plus, it depends on this quantity, this green color. So epsilon to the power 1 minus mu over 1 minus mu, right? But now this mu is yeah, so yeah, understand. So 1 minus mu, if if it's 1 minus mu is less than 0, then we understand that 1 minus epsilon to the power 1 minus mu will diverge. So this whole thing, the green thing will diverge. But when 1 minus mu is equal to 0, this whole term, whole these things will not valid. So this 1 minus mu is here in below. So 1 minus mu should not be equal to 0. So that we have to treat separately. But what we know, 1 minus mu is strictly greater than 0, then epsilon to the power 1 minus mu to the power 1 minus over 1 minus mu is converged to 0 as epsilon tends to 0. So what we know, when mu is less than 1 and it is greater than 0, it will be convergent. Because yeah, greater than 0 in this case means when mu is strictly greater than 0 means what you have, when mu is less than 1, any number, it is convergent. That up to that we know, right? When mu is less than 1. What about when mu is equal to 1? So mu is equal to 1, that already we have seen. It will be like dx over x minus a to the power 1 integration a to b, and we have seen like 1 by x also, with 1 by x dx it will not converge. So not convergent. So that we have seen in the first question. So what we have, this dx over x minus a to the power mu integration a to b convergent if and only if mu is less than 1. This is very strong result. Mu is a real number where mu is strictly less than 1. Any number, it can be any, so negative, positive, but it has to be strictly less than 1, not even 1. So you can use this epsilon definition and you can show that this is convergent when epsilon is, mu is less than 1. Is this okay? Did you understand what I have done here? See, first let's took this equation, mu is equal to 0, you see it's very trivial, it comes b minus a. So when you have an integration value, then it's convergent. So I mean, we don't need to worry about that, because this function, constant function 1, it has no problem with in a to b, and it's integrable, and you have there some value. And when mu is less than 0, it's a negative real number, so you can replace it by any negative of any positive number, and that is mu equal to minus m, m is greater than 0. So then you can use the same thing, and you can again you can great, and you will see it will not have any problem, and you can evaluate the integral. But when you have mu is strictly greater than 0, so you will see the problem reaches, because this 1 over x minus a to the power mu, that will have infinite discontinuity at x equal to a. So you need to exclude a, and you have to take limit of definite integrals mainly, or proper integrals. And then you have this limit of epsilon tends to 0 plus. You will see only SU comes in the pause, this green term is term in written in the green color, and that is now we evaluate depending on 1 minus mu value. If 1 minus mu value is less than 0, and that you will see it is like mu 1 minus mu is, let's say it's minus 1 by 3, you will see limit epsilon tends to 0, that will come as minus 3 times epsilon to the power 1 by 3, and that it blows up as epsilon tends to 0. And but when 1 minus mu is strictly greater than 0, it converts, it tends to 0. So this value will then exist, this 1 minus this limit epsilon tends to 0 plus. And that's why we say mu when 0 to 1, this is really conversion. And we have seen also when mu is less than 0 and equal to 0 also it converges. So we can say that when mu is strictly less than 1, it is conversion. And we can already see when mu is greater than 1 also, we have seen it is divergent. And what about mu is equal to at 1? Mu is equal to at 1 also, it will not be conversion, because we have seen this is a similar idea we can use like this: 0 to 1, 1 by x dx, which will be which diverges. So we said this is the same thing, 1 over x minus a to the power 1, so it will not be conversion. So dx to the power x minus a to the power mu converges if and only if mu is strictly less than 1. So mu is when mu is uh, even mu is less than 0, that is like proper integral, and you don't need to worry about mu is less than equal to 0. Most important range is 0 to 1, even though it is improper integral 0 to 1. From mu is from strictly less than 1 and strictly greater than 0, this integral is improper, but still it converges, it has some value. Hope you understand, otherwise please tell, because this was one of the important questions in the proper integral. Okay, so if you understand, then I'll give another question, maybe some other question. What can you say about the convergence of this one, depending on the p value? You try, I'll then do. Any idea about this? Yeah, I have given because Seth has also done like this type of thing. Like you can, I'll give a hint maybe. Okay. So if limit x tends to 0 plus fx over gx is equal to L, which is not equal to 0 and finite number, then f integration of f and integration of g, I mean improper integral, they are both convergent or both divergent. Both convergent or divergent. If one converges, the another will converge, and if one diverges, another will diverge. Mainly, you need to find the function gx. Assume fx is x to the p minus 1 over 1 plus x, and find the function gx as that there's limit x tends to 0 plus fx over gx is uh, diverges. Sorry, is equal to a finite number L. Yeah, and of course, f and g are both positive here. That you need to remember. And here 0 will be the point of discontinuity. So for this to use, 0 is the point of discontinuity, infinite point of discontinuity for both fx and gx. Huh? So in general you can write a. So this is hint. Okay, let's do it maybe. I think it will be it is little very difficult for you, or you are sending any message. If you please, you are writing something, instead of that you tell me. Okay, speak. 0 to 1 mainly x to the p minus 1 over 1 plus x dx. So this is p minus 1 when it is greater than 0. Or let's see if it is equal to 0. Then no problem at all, right? At 0 or at 1. So what I am saying is x to the power p minus 1 when p is greater than 0, x to the p minus 1 to 1 plus x has no infinite discontinuity or something, or like some blow up or something in 0 to 1, right? So only when the problem comes is p minus 1 is less than 0, right? So let's say p minus 1 is less than 0, so p minus 1 is equal to this, then it will look like minus m, right? Like I said, where m is greater than 0. So then what it will look like, it will be dx over, so 0 to 1 x to the power p minus 1 over 1 plus x dx is nothing but x to the power m 1 plus x dx. And now you see it has a singularity in at 0. So 1 by x to the power m 1 plus x dx, sorry, has infinite discontinuity at x equal to 0, right? It has a problem, so it becomes improper integral. So now you have to use you have to take a function. So this is a function fx. Let's say fx is equal to 1 over x to the power m 1 plus x dx, sorry, x, and you need to find a gx function such that fx over gx, and as at x equal to 0 it has problem, otherwise it has no problem, right? Only in find this at x equal to 0, at x equal to 1 it has no problem, and we do that also. So limit as then x tends to the point of discontinuity 0 plus is equal has to be is equal to L to find a function gx as that, where L is not equal to 0 and finite. And then you can, that function gx should be simple function, so that we can have a you can talk about the you know the convergence of that one. So what is that? Let's say gx is equal to 1 by x to the power m. Do we know about this function? So 0 to 1 by x to the power m, we have already seen, right? Because we have seen a to b 1 by x minus a to the power mu, right? So that's the same thing here. So that we know when it will converge or diverge. So when is that? So it converges when m is m is less than 1, right? Correct. Conversion only when m is strictly less than 1, otherwise it diverges, right? Otherwise it will diverge. Okay, and now if you see fx over gx, how will be that? Fx over fx is 1 over x to the power m 1 plus x, and gx is 1 by x to the power m, so that will be 1 by 1 plus x, and limit as x tends to 0, sorry, yes, x tends to 0 plus fx over gx is equal to 1 by limit of x tends to 0 plus 1 by 1 plus x, that is 1. So it is not equal to 0 and a finite number. So then what you can say, x to the power m integration, so 0 to 1, mainly we start with the 0 to 1 x to the power p minus 1 over 1 plus x dx is equal to 0 to 1 dx over x to the power m 1 plus x converges if and only if m is strictly less than 1 and diverges, so the otherwise diverges then, right? And what is the p value then? P minus 1 is equal to minus m, so it converges when p minus 1 is m is less than 1, so p minus 1 has to be, so p that you can write, right? 1 minus p is equal to m has to be less than 1. That implies that's what we have chosen, right? P minus 1 is less than 0. Yes. Right? That I have written it correctly. So that implies P has to be strictly greater than 0. P has to be strictly greater than 0. See, we got the convergence. So P is greater than 0. Then integration over 0 to 1, right? 0 to 1 is started, 0 to 1, x to the power p minus 1 over 1 plus x dx converges. See how important the result, but it was very easy to check using, instead of 0 we take 0 plus epsilon and we do the limit. Sorry, we don't need to do that, sorry. You need to it's like comparison principle kind of thing. You need to find a function gx which you know it very easily, and then you take limit of fx over gx. If that is a not non-zero number which is finite, then you can say that both functions are converges or diverges like together. Do you understand this?
Yes.
So there is one question which might be difficult for you, but similar. This is a similar technique. It's comparison principle. Using comparison principle, you can show that 0 to 1 x to the power m minus 1 times 1 minus x to the power n minus 1 dx. This is a special kind of function. You will later you will realize, or later you will read also. This function is also, this integral is convergent. Sorry, convergent if and only if m greater than 0 and n greater than 0. Both are positive number. Anyone knows about this function? Any special name? So Nitish is asking one question which I don't understand. Can you just turn on your microphone phone and you can speak? It will be better. This is like, yeah. You ask something, Nitish. So Niti's question was 1 for 1 by x. We did not do only for 1 by x, right? I think you asked before this question. So for this type of question, so this is here 1 plus x to the power p minus 1 over to the power 1 plus x. You have comparison principle, right? You do it at a different step. Yeah, when you don't have for general any function, you can do all the methods for any function. So here maybe epsilon definition will be difficult. So somewhere it will be easy. So that's why different type of techniques are there. Like this is comparison principle. It makes this question much easier. So you have to, when you just practice a lot, you understand which method to use for which question, right? You have many like techniques, and you have to use that properly. That is the thing. So everyone knows the techniques. Everyone knows the what are type of the questions might be, but still, which one to use where, that is the game. Like that is where the problem. So that is where the you have to practice a lot. Yeah, and so your question was only for 1 by x we approach, but it's not only for 1 by x, and you have seen this for even with 1 by x, we have that 1 by not only 1 by x, that is 1 by x to the power mu, and that converges or diverges. That was important because for this type of question also we can use that thing. We have compared that function fx with the 1 by x to the power m, and we see the it converges or diverges, right? And yeah, that is one of the good examples. So that's why I did for 1 by x. We can do for many other, but it will be used. See, even if you have a sine type of function, you will see sine x over x, limit x tends to 0, is tends to 1, and that is using comparison function. You can say that 1 by sine x or some such thing that is convergent in some interval. So 1 by x is important in this integration. So anyway, I don't know whether I have given answer to your question, but as you are not switching on your microphone, I cannot always just check it. Still, I checked. If you have that, still you are writing, and it's okay. I'll check again when I go to check the chat box. Okay. Otherwise, I'll go ahead with this type of question. Also, you can do using the same methodology like the comparison principle. You can find a function, but you have to do as this calculator, little bit calculated. But yeah, now I come to the question I asked. Do you know about this function? Any speciality of this function? First of all, it's convergent if and only if I can prove that m is greater than 0 and n is greater than 0. Advait, you know? I think you are here.
Yes,
What is the function name?
no idea.
Okay, no problem. I just these are called beta function. Okay, you will know later. So some properties you have. This is a nice properties, and this is called beta function. Okay, beta function. I mean this beta. I mean beta function is beta of mn. Beta of mn is this integration 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1, and that is you hopefully you understand that is beta mn is defined only when m is greater than 0, n is greater than, because we know m, when m and n are positive, then only this this integration, this integral converges. Okay, and this convergence is very okay, this convergence analysis is very easy, like using your this comparison principle that you can show, and this beta function you will see have many nice properties later. Okay, but this is called beta function. That's the only thing you need to know now. You don't need to worry about anything else, just know the name. Otherwise this, yeah, so this is complicated type of function, 1 to x to the power n minus special function x to the power minus 1 or minus x to the power n minus 1. So you will see this has a singularity when n is less than 1 and m is strictly greater than 0, that has singularity at x equal to 1. If when m is less than 1 and n is greater than 1, that has singularity at x equal to 0. So it has two type of two different, even m is less than 1, n is less than 1, then it has singularity at both 0 to 1, 0 and 1, right? So yeah, so that is the thing I wanted to say, but I can very easily check it if you try it at home. Otherwise I will do it in the next class maybe. It's very a little bit calculated, that's all, nothing else. Yeah, let's say 0 to as what's the name? I forgot the name. Nitish said this only we are doing for 1 by x type of function. So you will see everywhere, most of the places 1 by x also plays important role in evaluating the function. Okay, the integral. So can you say something about this integral, whether it's convergence or divergence? I'm just telling you, can use the comparison principle and the result that 1 by x to the power mu is convergence 0 to 1 or 0 to 1, even 0 to any a or b, because it does not matter, because only problem was at 0. So 0 to a 1 by x dx, even you can show that 1 by x to the power mu dx is convergent if and only if mu is strictly less than 1. So you use that fact and comparison principle to show that this is, I don't know whether convergent or divergent, because using the comparison principle you can show both convergent or divergent. Okay, so yeah, this question you tried, as Nitish is asking whether it's given. So you have to prove manually, like I did here, right? I did here. This one also x to the p minus, so not here. So in this question, when conversion, it was I was asking, but I am now it is, let's say I am giving you the question that conversion is true. Prove that conversion if and only if it is, sorry, here, if and only if it is m greater than 0 and conversion. You have to merely prove that, right? It's a question. It's not given. Given in the sense you can assume m greater than 0 and greater than 0, then you can prove it is convergent. But you have to show that also when m is greater than 0, n is less than 0, or m is less than 0, n is greater than 0, for any all other case, it is divergent. So that's all. Okay, then you do this list. Okay, so this one you have to mainly use. I told, although it's a comparison principle, this little difficult one might be. So what you need to show that limit, you will see it has problem only at x equal to 0, right? That at least you understood, because 0 to pi by 2 sine x is only 0 when sine x is equal to 0. Otherwise not 0, and if not 0 then it has no problem, because log of something else other than 0, any positive number is defined, right? So only the problem at x equal to 0. So limit x tends to 0 plus fx over gx, you can find a function such that it is equal to 0, although is equal to 0. But if you have, in that case, you cannot say both convergence divergence. You can say that if this 0 to pi by 2 gx dx is convergent, then this 0 to pi by 2 is not if and only if condition, if it's not divergence condition. So gx dx, fx dx also convergent. And let's not maybe do here. So gx is, you can take 1 over square root of mu as a square root of x, and we know already, right? 0 to pi by 2 1 over x to the power square root of x mean dx, mainly to make it more visualized, to visualize more precisely. X to the power half, and half you know is less than 1, so it's convergent, right? And only other thing to prove is x tends to 0 plus fx over gx log of sin x over square root of 1 over square root of x. That's nothing but limit of x tends to 0 plus square root x log of sin x. We can show that that is equal to 0. So using the comparison principle, and that comparison principle is this one. So this comparison principle I mean, you have to use. It's a little different, but yeah, you can easily remember. So if I showed that limit x to 0 plus fx over gx is some non-zero finite number here, even if it is 0, then what only you can say that if it is convergent, then 0 to pi by 2 fx dx will be convergent. So we can find out when this will be convergent. So yeah, and you can show here that it is converges. It converges. See, this function was log of sin x, some different type of function. Still, we used the fact that 1 over x to the power mu is convergent. That fact, 1 over x to the power half is convergent, right? So that type of. So there are see this type of many type of examples I can do. And I hope you all of you know, if I was always doing this A to B, right, finite things, and if it's 0 to A to, let's say, infinity, then you can think it as limit as m tends to infinity A to m, right? This is nothing but. And when you had this A to B and you had a problem, what you do, limit epsilon tends to 0 plus A plus epsilon to B. If you had a problem at B, then you could do is A to B minus epsilon. So just it's A to B, sorry, A B you have, wherever you have problem, if it's a problem at B, you take up to B minus epsilon. You have problem at A, you take A plus epsilon, right? And now if you have A to infinity, so you take any m which is bigger than 0, bigger, and you approach infinity, right? If you have minus infinity to A, that also will be, it will be limit of m tends to infinity minus m to A. So all these things are very easy now to see, right? So knowing this, we can do some other example where yeah, so if it's 0 to infinity 1 by 1 plus x dx, can you say anything about this? This has where it has problem at infinity, so it's improper integral due to the fact this 0 to infinity is there, right? And at infinity it is blowing off, right? So but what you can show, this is nothing but limit as m tends to infinity 0 to m 1 by 1 plus x dx, right? And that is nothing but limit as m tends to infinity, this is ln of 1 plus x, and you have 0 to m, when it is m, it will be ln of 1 plus m, and it is when it is 0, it is ln of 1, that is 0. And you know, as ln 1 plus m, lm as m tends to infinity is infinity, or it converts to infinity mainly. Because a log function looks like this, and as even log 1 plus x or x, it does not matter, it will converge to infinity. As you approach like m tends to infinity, ln of m or 1 plus m will approach to infinity. So it diverges. The integral diverges. So it you can have the comparison principle here also, You can use those. You can show that 1 by 1 plus x square. Like when you have 1 by x square, you will see it will converges if you want. So what I'm saying, 0 to infinity, you can check it 1 plus 1 by x square, that will be convergent. If it's 1 plus x, it does not converge. So you can have this thing also 1 by x 1 by x 0 to, sorry, 1 by 1 plus x 0 to infinity, when it converges, when it diverges, that you can also say using new things. Okay. Okay, so all those things I mostly leave it to you, because these are like okay kind of. So yeah, but I'll write maybe. So let's say a to infinity dx over x to the power mu, uh, a is a positive number, of course, otherwise it will be improper at a also, at, yeah, at a also, at, sorry, at 0 also, and so that's why a is greater than 0, and you can show that it's convergent if and only if mu is greater than 1. So how it, how it differs, when it was 0 to 1, mu has to be strictly less than 1, and when you come to a to infinity, it becomes mu has to be strictly greater than 1, right? So that you can check it very easily. You can take the limit of n tends to infinity and a to m, right? I should not worry. You want me to do this? You can just check it for some time, like 2-3 minutes I give you. You can check it if you want. This is okay, right? I'll proceed then. Hmm? Mainly what I'm saying, this a to m, you find out limit as m tends to infinity x to the power mu. You will see when only when mu is greater than 1, this limit exists. when this mu is greater than 1. This is very easy to check out this. We have done many things, so it will be very easy for you. Okay, so let's do this sin x over x, whether it's convergent or not. See, I am mostly doing the improper integrals because there's a more harder than the proper integrals, so definite integrals, and this area and all these things. Maybe I'll do one question one from area, like how to find out from definite integrals, but mainly these are the improper integrals which are difficult, and they should be people should look at it with the people should give more time on this improper integral. Yeah, so that's what I'm doing. This sin x over x. So what about the sin x over x at 0 to infinity? How do you check that this is convergent or divergent? So what you will see at its limit as x tends to 0, sin x over x, that is we know 1. So it has no problem at x equal to 0, and also you will see at from 0 to any bigger number it has no issue. So this 0 to infinity sin x over x dx can be written as 0 to less than 1 sin x over x dx, and we know it has no issue this integral because it's has no discontinuity or something, and 1 to infinity sin x over x dx. Why I'm taking, you will see understand. So we know what. So now we need to find out whether sin x over x dx is convergent or not. We know about this function. This has no issue because it has it's a proper integral, right? And sin x over x will be so that in an integral. But sin x over x dx, what do you know about sin x over x dx? How do you check that this is converges or diverges? So this type of question is not like easy. Okay, that's why I try to give you one test is like this. If you have a to x fx dx is bounded, a is a positive number, huh? Bounded on a to x, and you have a phi function which is monotonic. Monotonic means increasing or decreasing, and bounded on a to infinity. So this is for all x, and monotonic is on the boundary a to infinity, and limit of x tends to infinity phi x is equal to 0. Then you can show that a to infinity fx times phi x. It's very strong result, it's very important. It's convergent. So a to x fx dx has to be bounded for all a to x on a to bounded on a to x for all x, and phi has to be monotonic bounded on a to infinity, and x tends to infinity phi x is 0. So in our case, let's say phi x is equal to 1 by x, and all of you knows that phi x is bounded on any a to infinity as positive, right? And it's monotonic, it is monotonically decreasing. Also, we know limit as x tends to infinity, 1 by x is equal to 0, right? And now we need to check a to x. What was our question? Sin x over x, right? Sin x over x, whether it is bounded on this interval, right? But what is this? This is nothing but, if you take modulus of this will be less than equal to okay, not sin x over x. This is sin x, right? So need to do this on business. So sin x. So sin x. So sin x dx is nothing but minus of cos x, and this will be minus cos x plus cos a, and that is nothing but less than equal to 2, right? So bounded function. So a to x for all x is true, because x for all x belongs to a real number r. So a to x sin x dx bounded for all x. 1 by x is bounded on monotonically decreasing on a to infinity. So then we can say that any a to infinity, and you can take a is equal to 1. So 1 to infinity fx dx. Here fx is sin x, okay? Fx is equal to sin x. Fx times phi x. So sin x times 1 by x. So sin x by x is convergent. And you know, we knew that 0 to 1 sin x over x was convergent because it has no problem. Sin x over x is very nice between 0 to 1. So we can say that 0 to infinity sin x over x converges. So one more thing I would like to say is that finding the value of this therefore per integrals are not easy. So that is next level. So you can, you know, the how whether it's convergent or divergent. First, whatever I have done, mostly they are convergent or divergent. That we have checked. But for to know the value, exact value, you need to know other things like beta function, gamma function. So using that, mostly people find out the integration values and all. Okay, so that is the next thing. But other thing, but this is how you can find whether the function is at the other integral is convergent or not. Because to evaluate the integration values, you might need to know about the series and also, but I have seen the series is not done till now for your in your course, but later it will be done. So once those are done, then you can again come back and try to find out the value of the this improper integrals, but otherwise just forget this. Forget to now don't need to do any evaluation of these improper integrals. Hmm? So if you have any other question, I think many this idea of how like not the whole thing you got, but at least this a few things you got about this improper integrals. To check, you to just take one book and do other things. So if you have your assignment question, I can do. Otherwise, I take it from the old assignment questions. And before that, I'll check if you have any question in the chat box. Okay, so no questions. I think assignment was much easier, like this type of question in the previous year, at least I can say. Let's say they're asking to find out Cauchy principal value, I think, right? That's called Cauchy principal value of minus infinity to infinity, z to the power 2a plus 1 plus z to the power 2a minus 1 dz. I mean, z is, I mean, real number. Z don't think is a complex number. So Cauchy principal value, I think it is yeah. What is a? I'll just write it because a is not written there. I think a is, yeah, a is greater than equal to 1 and a belongs to z. So how to find out the Cauchy principal value? Cauchy principal value is nothing but this limit as p tends to infinity minus p to p z to the power 2a plus 1 plus z to the power 2a minus 1. So mainly this Cauchy principal value is nothing but the limit of this. But so mainly I will not write this as limit p tends to infinity. This is equal. So it is Cauchy principal value. So this is equal to Cauchy principal value. Cauchy principal value. So Sarah has also told that this Cauchy principal value uh, is sometimes finite, but it might happen that the integral does not exist. So that time it was like people were trying to find out many way, and he gave some way that in his this Cauchy principal sense, this limit evaluated. So that is like this: limit p tends to infinity minus p to p z to the power 2a plus 1 plus z to the power 2a minus 1 dz. Okay, and this limit, what you can see is a z is integer, and so limit as p tends to infinity z to the power 2a plus 2 over 2a plus 2 plus z to the power 2a over 2a, that is minus p to p. And you know this is limit as p tends to infinity, it will be p to the power 2a plus 2 to the power 2a plus 2 plus p to the power 2a over 2a minus minus p to the power 2a plus 2. What is that? That will be 2a plus 2, because 2a plus 2 is integer. Sorry, even integer, even number, right? A is not real number, a is integer, so it will be minus p to the power 2a plus 2 will be p to the power 2a plus 2 and minus p to the power 2a, that is also again even an integer, so p to the power 2a over 2a, and that will be 0. So its Cauchy principal value is 0 and it is finite. So that was one of the question from your assignment, the previous year's assignment. So these are the easy questions, and another question was find the area of region bounded by, so bounded by the curves z is equal to x e to the power minus x, so instead of writing z, let's write as y, x to the minus x, and x axis from x equal to 0 to 6. What you need to do is have a function, which is a curve y, some curve, let's say I'm not writing precise curve, so that you have to take 0 to 6, and you have to, the region bounded by x equal to 0, x equal to 0 will be this line, and x equal to 6 will be this line, so this area. So mainly how do you find that? Will be x equal to 0 to 6, x to the power minus x dx. And this type of question is there, like in your thing. So x to the 6, x is the minus x. How do you integrate then? So what you have, x times integration of e to the power minus x, right? Minus ddx of x, integration of, and integration to the minus x, that will be from 0 to 6, right? Dx, this whole thing will be from 0 to 6. That's nothing but x to the power minus x, negative of this first integral, minus integration of negative e to the minus x, this will be plus e to the power x dx. That whole thing is from 0 to 6, and that is equal to minus x e to the power minus x plus e to the power, sorry, it's a minus x, minus x, so this will be again minus of e to the power minus x 0 to 6. So that is nothing but minus 6 e to the power minus 6 minus e to the power minus 6 minus 0 plus 1. So that will be equal to 1 minus 7 times e to the power minus 6. That is the area of the curve this between this x equal to 0 to 6. So these type of questions are there. So easy, I would say. So I told about this Cauchy principal value, right? So Cauchy principal value mainly when you do, you have infinity to minus infinity to infinity, that is nothing but treated as, so not treated as that. For that, if you want to find Cauchy in the sense of Cauchy, then that has to be minus p to p, limit as p tends to infinity. But when this is converges, if integral this infinity to infinity fx dx converges, then minus infinity to infinity is equal to limit p tends to infinity minus p to p. Otherwise it may or may not be. So if it is divergent, you can find a function such that in minus infinity to infinity, that function fx dx is not equal to that might be divergent, that integral is diverges, but p tends to infinity minus p to p converges as limit p tends to infinity. So Cauchy, in the Cauchy principal value, in the sense of Cauchy principal value, Cauchy principal value sense, it's the Cauchy principal value of the integral might exist, but the function that the integral in minus infinity to infinity might not exist. So that is not always equal to this. So minus infinity to infinity fx ds is not always equal to. So it might be not equal to also. Yeah. So that is something I wanted to just point it out. And then all other questions I find is easy, so I don't need to worry about those things. Sixth. If you have specific question, you can ask. Otherwise, I'll try to end today's session because today I don't have much things to tell. Yeah, that's another question maybe I can give like here. Something like this. So 1 to infinity, 1 minus e to the power x over x dx, whether it is converges or diverges. So or diverges. It was your one of your this assignment question. So 1 minus e to the power minus x over x can write as 1 minus 1 by e to the power x over x, right? Yes. And that is equal to 1 by x minus 1 by x e to the power x. Yeah. So and then 1 to infinity 1 by x. So whole thing will be equal to 1 by x dx minus 1 to infinity 1 by x e to the power x dx, right? And what do you know about 1 to infinity 1 by x dx?
Divergence.
Because it will converge only when x to the power 1 by x to the power p converges only when p is strictly greater than 1, right?
Yes.
So even if it is you can show that it is converges, then you can say this whole thing will be divergent also, because this 1 by x e to the power x is greater than 1 by e to the power x, right? So sorry, less than, it will be less than. Why is I show you why. Let's write from first. E to the power x is a positive number, right? And you know x is greater than 1 in this interval, like x in this one, x is greater than 1. So x times e to the power x will be greater than e to the power x, because e to the power x is positive. That implies 1 by x e to the power x is less than 1 by e to the power x. So integral value 1 by x e to the power x from 1 to infinity will be less than equal, dx will be less than 1 to infinity e to the power 1 by e to the power x into minus x dx So that you will see it will be like it will have a value and it's in minus infinity, because e to the power minus x is minus e to the minus x, that 1 to infinity it will be I'll be writing, so minus x, of course, minus x. So minus it will, at infinity it will be 0, so plus e to the power minus 1, so mainly 1 by e, so that's less than infinity of number, so it converges, although this term converges, so but you have this one which is diverges, so you can say that it's diverges mainly. If the second term was divergent, you don't know, might happen something. So, but its first term is convergence, but second term is divergence. So, kind of thing say that the whole term diverges. So, this integration mainly 1 to infinity, 1 minus e to the power minus x over x diverges. So, this type of questions were there, and then they have given the function that f(x) and f and g are two odd function, then f plus g will be odd, so those you can do. Yeah, so if you have any question from your assignment or something, you tell, otherwise I will just end today's session, because it was not much things to do, mostly just find out the integration value and all these things, so nothing else.
I don't have any question.
Okay. I mean, I'll end then today's session. I will not tell, ask, or anything. I'll just do by like doing one another question, and that is from definite integral. As I started, you will see here I wrote things also. We'll do improper integral, calculating independent integrals. That is, I think it's not done. I'm sorry for that. That is not done, means not for this course, but few things you can do. And improper integral we have done. Now only we need to do this application of definite integral. One we did, but that was very simple. So that's why I'll do another, and I'll just uh, end today's session by doing that. So that is the question. Sorry, not question one, some question number will be there. That is, determine the area of the region enclosed by y is equal to x square and y is equal to square root of x. Can you do this? So for this
Yes.
area type of questions, you need to mainly draw properly what is the curve, right? What is the graph? So y is equal to square root of x looks something like this, and y equal to x square, because y equal to square root of x does not exist beyond x equal to 0 on the left side, and y equal to x square will look like something like this, and the area will be this portion mainly. Area will be this portion, but how do you know from where to where this is? So this is 0 point, so you don't have any problem. But what is this problem? What is this point? Sorry, what is this point? So for to know this point mainly, so if you know this point, then 0 to that point, let's say A, then and you have this above point is square root of x, so and minus x square dx, then that will be the area, right? Because you have to first take area of I'll Why? You will say you have this area of this whole thing, and that area will be the area of square root of x dx, and you have area of the square root of x square under this curve y equal to x square, that is y equal to x square, y equal to x square, and that is this blue line, and this yellow line area minus blue line area is equal to the area of this green lines, right? So that's why you do this business here, but only need to know about the point where it this point. So for to know this point, what you need to see, when square root x equal to x square, right? So one point is 0 0, that is true, that we have seen, we can see also, but other what point at which this is, they are equal, and you can see x equal to 1 also will be another point, one possibility, right? And all other point is not, because x to the 4 is equal to x square root of x equal to x square means x to the 4 equal to x, and that implies x times x cube minus 1 is equal to 0, and that will have x times x minus 1 will be another, and another will be x square plus x plus 1. I think that will have imaginary root, and that's why x equal to 0 and 1 are the only real solutions. So a will be our case, it will be 1. So 0 to 1, if we know square root x minus x square dx, then we will know the answer of the area what they are asking, enclosed by y equal to x square and y equal to square root x. So don't forget to write square root x first, then subtract it, subtract x square from square root of x. First square root of x, then x square, right? That is because this thing, the green line and yellow line, by that I wrote. So now it is easy. What is the area? So first square root of x is x to the half, so then it will be x to the 3 over 2 over 3 over 2, right? Minus x square is x to the power 2 plus 1 3, and 2 plus 1 3 here, and that will be from 0 to 1, right? And when you have this 1 at 1, it will be this minus 1 over 3, and it will be 0 plus 0, right, at 0. So it will be 2 over 3 minus 1 over 3, that is 1 over 3, and that is your area will be 0 0.333, and like that. So that's how you can, so area, not area enclosed by the curve y equal to x square and y equal to square root of x. So what you will see, if you start with first x square minus square root of x, you will find it as a negative of 1 over 3, so which cannot be also. So this is the area. So this is how also you can find out, this is how you can find out area between two curves. So mainly need to find the point of intersection, and you do the same business. You know the area of the curve if under the curve, so area under the curve if x is integration of 0 to that infinity or 0 to whatever the function define fx dx, and you just subtract to area, you get the area between that two curve enclosed by x square. So you can have some other different type of which can be little difficult, but yeah, so at least if you know this idea, you can do it for other curves also. So you can have a different type of curve where you need to do it little differently. Let's say you have like functions like this, you have, let's say, curves like this, you have like this, and then you have this to this. So you have then it's just defined on this, so this area and plus this area and plus this area. So you need to know about this 3 point of intersection, and here also you need to, we have maybe, let's say, a to b is given, but you need to find the area points here, and then you take take the value integrate between this by separating these three, and you add it. So that type of things also it can be, but mostly you need to, so separately you need to do it so that the area don't become negative or something. Anyway, so I think for today it is done, And yeah, thank you for your attention. I'll end today's lecture. I have some other work also, and I think time is over, and I have done few things. And like I said, it's a beta functions. That thing also you try, and many other questions are there in the any textbook. You try, and if you have in doubt, you just send me an email or by like an email or the YouTube. The YouTube itself, you can comment or somewhere wherever you find it's easier for you. You tell me, I'll reply. Okay.
Yes, sir.
Okay. Thank you.